All right, so sorry about this. I actually did the video and then I had to delete it because I didn't have enough memory. So I spent about half an hour trying to get rid of all my videos on my phone. Okay. Oh, so this one is just asking about the direction of the particles. So they give you the position. So you have to find the velocity components. So remember, if the horizontal velocity component is negative, then the object is going to move left, right? So this is -2, the derivative, so it doesn't depend on t, it's always -2, so the object will always move to the left. So we have to decide whether it's going up or down. So the derivative is 2t, but we have to find what t is at this given point. So at this given point, y is -2, so we would have to let the y here be equal to -2, so we could figure out what t is, so we could plug it in here. So we figured out t is 1, so we plug it in here and we get 2. So that means that the vertical component of velocity is positive at that point, meaning the object is moving up. So it's moving left and upward, which would be that choice A. I knew it wasn't C, D, and E once I realized that it has to be moving to the left. That's why I crossed those 3 out. Oh, and this one, number 9, that's just a formula for Euler's method. The thing to realize here that it's different from the other problems that we've seen, though there was one like this on one of the homeworks from Best and Lux, is that you're going from, you're starting at x equal to 1, you're going backwards to 0. So your x sub 0, y sub 0 are the given x and y, which is 1 and 2. And then your next x sub 1 would be 0.5, and then your x sub 2 would be 0. But delta x would be -0.5 because you're going backwards. So that's the formula. And to plug in the numbers, y sub 0, that's the original y value, which is 2. The slope at x sub 0, y sub 0 is the slope at this point when x is 1 and y is 2. If we plug those in here, 2 times 2 is 4, minus 1 is 3, right? So that's where this 3 came from. And then delta x is -0.5. And doing the math gives you 0.5. So that's y1. And then you do the same thing to find y2. But y2 now is based on y sub 1. This is a recursive formula, if you remember that from Algebra 1 and Algebra 2. So our y1 we just found is 0.5. We plug it in here. 0.5 plus, now we have to find the slope at x1, y1. So x1, y1 is 0.5 comma 0.5. And once you plug it in there, 2 times 0.5 is 1, minus 0.5 is 0.5. So the slope is 0.5 at this point. Everything's 0.5 at that point, geez. And then delta x, which doesn't change, is -0.5. So when you do the math, you get 0.25, which is choice C. Okay, number 10. This was a lot of work. I erased it because I really want to do this from scratch with you. And we literally have to go through every single one, which is a little bit of a lot of work. Number 1, though, isn't too much work because if you do the not the sign analysis, oh man, it's getting too late. If you do the divergence test here, the limit of the nth term is not 0, it's 3 as n approaches infinity, right? So this diverges by the divergence test. Because 3n over n, that would give you 3 if you took the limit as n approaches infinity. So this diverges. Okay. This is not, I can't use a divergence test because the limit will be 0. But I can do the comparison test. I would compare this to 1 over n. And 1 over n is smaller. You can see this by cross-multiplying n and 3n. You can do that because all these values are positive. N and 3n is 3n squared, right? And n squared plus 2 times 1 is n squared plus 2. Right, so you can clearly see that the inequality holds. So part B diverges because by the comparison test, when we compare it to the harmonic series, which is smaller and diverges, it diverges. Okay. Part C, I would like to simplify this a little bit. If you notice, you can divide everything by n. So you could just get 3 over n plus 2. But this is really the harmonic series. The first term here is 3 over 3, which is 1. Yeah. I'm trying to think of the easiest way to do this. So you get 3 over 3, which is 1, plus 3 over 4 plus 3 over 5. It's basically the part of the harmonic series, right? So that diverges. This is nasty because you have to go through every choice unless you pick the right choice to start with, which is highly unlikely. Okay, part D, I can't simplify. I can't use the divergence test, so I go for the divergence test because it's the easiest to use. But I can compare this to 1 over n cubed. Let's see. No, I'm sorry. Why 1 over n cubed? Hello. 1 over n. Because again, we're looking at the leading terms. I could leave 3 here. Let's see if that works. 3n squared over n cubed is 3 over n. And I want this to be smaller. So let's see. If I cross multiply, I get 3n cubed is bigger than 3n cubed plus 2n, which is not true. So making this anything but make this 10 if you want. You can make it as big as you want. Okay. So this is still harmonic and diverges, and it's smaller than that, right? Because when you cross multiply, you get 3n cubed greater than 10. What the hell did I do? N cubed plus 20n. No, that won't work. How about if we do 1 over 10n? Then it'll work really well, because then you get this 30n cubed, and you get just n cubed plus 2 on the other side. N cubed plus 2n. So you could do it that way, right? And this is the same as the harmonic. It's just a 1/10 you can factor out. So that's it. And E has to be the answer because, yeah. And this converges because you can compare it to 1 over n squared, I guess, which is a P series, and 3n to the 4th. 3n to the 4th, and this gives you n to the 4th. But we want this to be bigger, so you could do that. Okay, so P series converges since the power is greater than 1. So it's a lot of playing around with these series, man. A lot of work. Okay, 10. I would skip this problem, actually. I would skip it since you have to do every single one of them. And I would just come back to it if I had the time. And otherwise, I would guess. Okay, so we're up to 11, I think. Yes, okay. All right, 11 is, just a formula. You need to know your formulas. So the antiderivative of 2 to the t is 2 to the t over ln of 2 plus e to the pi is a constant. So it's just e to the pi times t plus c. So which choice is that? It looks like it's choice B. Okay, so these are just formulas. Nothing special. Okay. So they're making up on this question all the time that we had to spend on the series question. Looks like L'Hopital. Usually the limits are L'Hopitals. Do we get 0 over 0? Yes, we do. Because when we plug in 0, we get 1 minus 1 over 0. So 0 over 0. Using L'Hopitals here, you get limit as x approaches 0 of e to dx, which is 1. So choice is C. No special anything there. Okay, I had to start on this one because you really need to remember the formula. Okay, though here, yeah, you still need to remember it. So dp dt equals k over m times p, m minus p. That's the formula, okay? And we need to figure out what m is, okay? So we have to make this look more like that. Or the other way around, doesn't matter. Let's see what would be easier. Okay, I'm going to factor out the 1 over 5,000 from here. I'm going to pull it out of the... So then I have 5p over 5,000 times 5,000 minus p. So stop there for a second, see if I confused you at all. I just factored out the 1 over 5,000 from here. Right? So think of this as 5,000 over 5,000 and factor out 1 over 5,000. So you're left with the 5,000. And yep. Okay, so my m is 5,000. And you know that that's the maximum capacity. So the limit as t approaches infinity of the population will reach maximum capacity, which is 5,000. So this is correct. So no calculus yet. We just use the formula. Okay, the derivative is positive. Well, I guess because the population starts at 1,000 and it's going up to 5,000, so the population is increasing, right? So that would have to be right. The second derivative is positive when t is greater than 0. Let's find it. Let's find the second derivative. It's not that hard. dp squared d squared p dt squared. So product rule. Or you can multiply through and do it that way. Maybe that's easier. So if you multiply this, it's 5p minus p squared over 1,000, right? Yeah. Okay. So the derivative there, so it's 5p prime minus 2p prime over 1,000. So p prime, this is just 500. 5 minus p over 500. Okay. So the derivative is positive. We know that from part 2. So this is going to be positive. But this won't be because p starts at 1,000 and goes up to 5,000, right? So this is not always going to be positive. Like, for example, when p is 5,000, 5,000 divided by 500, that's 10. 5 minus 10 is going to be a negative number. So 3 is not true. So it's got to be choice D for that. Excuse me. Okay, I just have 14 to go in here. You see, as the test moves on, it is getting a little more tedious. Okay. Oh, I like this one. This is cool. Because it's so easy, if you think about it. Okay. To me, when I looked at this graph, it kind of looked like the cosine graph. So remember, the cosine graph looks like this. It's got the same shape, but it goes up to 1, right? So this one is sitting on the x-axis, so it looks like this one that's been moved up 1 unit. So what I'm trying to say is this looks like, I'm not saying it is because this doesn't end at 2 pi, but it's pretty close. 2 pi is about 3.6 something, and this is 4. So this looks like cosine having been moved up 1. So what do they want? The graph, what is the following? F prime. So F prime would be negative sine, which would be choice D. Okay, and that's it. Bye.